On another page we can see Newton setting out his mathematical results about music in the form of a substantial table. Again, it's to many decimal places, 8 in this case. So we can see Newton setting out, comparing two different forms of the musical scale. He's aware of what would come to be called equal temperament, where you divide the octave into 12 equal parts, call them semitones, and build up a musical scale from that. But he's also aware of more complicated arrangements which have a longer history. Something he's particularly interested in is something called just intonation, where we insist that certain musical intervals must correspond to certain mathematical ratios. So if this scale were expressed using a set of strings identical in all respects except length, some of those lengths would form simple or interesting ratios of whole numbers with one another. Whole tones, for instance, the interval from C to D or F to G have to have the ratio of 9 to 8. Perfect fifths, the interval from C to G or G to D, have to have the ratio of 2 to 3, and so forth. There's a series of mathematical constraints on where the notes can go. If you work those constraints through, you get a particular form of the musical scale, which has certain peculiarities. It's not clear that it was ever actually used in practice. Certainly it was not taken up by practical musicians with any enthusiasm, but it was popular among mathematical theorists. This is the scale called the just intonation. So what he does on this page is to set out that scale, the just intonation, first just as a set of ratios, then as a set of large whole numbers. So imagine that we've got a set of strings. The largest one is, in this case, 720 units. And that, as it happens, makes all the other strings which make up the scale have lengths which are whole numbers of units. So that's a carefully chosen number to produce that result. Then he does more mathematically complicated things. He sets out the corresponding lengths of strings for equal temperament, which are not whole numbers. They're long, complicated decimals. And he also takes the logarithms of these two sets of lengths of strings.